In the next two videos, we need to do some theory in order to be able to get a handle on how to solve second-order linear differential equations. So the first idea that I need to introduce is called the principle of superposition. So let's write down a general second-order linear differential equation, x double dot, so d squared x dt squared, plus some function of time times x dot, plus some other function of time times x. And then we'll consider what's called a homogeneous equation, where the right-hand side in this equation is 0. Okay, so every term has an x on it. The principle of superposition states that if we have two solutions, so suppose x equals capital X1 of t and x equals capital X2 of t are solutions. Then the principle of superposition says that x equals a constant, c1, times x1 of t, plus another constant, c2, times x2 of t, is also a solution. Okay? So the principle of superposition says that if you can find two solutions to this differential equation, then you can multiply them by constants and add them and still have a solution. We'll be using this as a method for solving second-order linear, here homogeneous differential equations. So how do you prove this? The proof is quite straightforward. We take our x and substitute it into the differential equation and show that we get 0. So we have our x double dot plus p of tx. So let me just drop the t. So p is a function of time times x dot plus q times x. And then we need to differentiate our proposed solution. The derivative, we use the sum. The derivative of the sum of two functions is the sum of the derivatives. So this is equal to c1 times x, capital X1, double dot, plus c2 times capital X2, double dot, from the x double dot term, plus p times c1 x1 dot plus c2 times x2 dot plus q c1 x1 plus c2 x2. And then we can collect the terms that have c1 and collect the terms that have c2. So we get c1 times x1 double dot plus p x1 dot plus q x1 plus c2, and that has the x2 terms. So we have c2 x2 double dot plus p times x2 dot plus q times x2. Okay? And we have the assumption that x1 is a solution of the differential equation, and x2 is also a solution of the differential equation. So that means this term in the parentheses is 0, because x1 solves the differential equation. C2 times this term in the parentheses is also C2 times 0. And so 0 plus 0 gives us 0. Okay? This is the proof of the principle of superposition. So let me briefly tell you what I did. We have our second order differential equation. It's linear in x, right? And it's homogeneous, meaning that the right-hand side is 0. When you have such an equation, if you can find two solutions to this equation, here capital X1 and capital X2, then you can form a general solution of this equation by multiplying each of these solutions by a constant and adding them. This linear superposition of solutions is also a solution to the original differential equation. And this is the very simple proof of that. I'll show you how to use this when we solve homogeneous linear differential equations. But in the next video, we'll need one more theoretical idea. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.